All right, my secondary math 1 class, we are going to be continuing to talk about the Pythagorean theorem. I know you guys are all loving this by now, but we are going to use it in word problems today, okay? So let's go ahead and find the missing sides of our triangles using the Pythagorean theorem. So remember, the Pythagorean theorem we use when trying to find missing sides, okay? We've been working with angles a little bit. We're not going to work with angles today. So we're going to find the missing side. So let's go ahead and remind ourselves what the Pythagorean theorem is. So let's go ahead and write that in the top of our paper. Pythagorean theorem is always a squared plus b squared equals c squared. Okay, and remember, if we draw a little right triangle, we want to know what the a, b, and c sides are. Okay? So we know that in a right triangle, the two sides that make up this right angle, those are legs. So that's a leg and that's a leg. And then our side that is across from that right angle, that is our hypotenuse. Might run out of room. Okay. So our legs can be A or B, and it doesn't really matter. Okay, all that matters is that our hypotenuse is C. Okay, but you guys are professionals at that by now, so let's go ahead and look at number 1. Okay, so let's go ahead and identify which sides are A, B, and C for number 1. Okay, so if we want to quickly identify C, that is across from our right angle. Okay, that means I can make XA and 3B. Okay, as long as that 5 is your C, you are good. Okay, so now that we have that, let's go ahead and just plug it into our Pythagorean theorem. So A squared, my A is X, so X squared. Plus b squared, my b is 3, so 3 squared, equals c squared, my c is 5, so 5 squared. Okay, let's go ahead and start solving for x. Before we do that, let's simplify. Okay, so let's start with x squared. Can we simplify x squared if we don't know what x is? No, so that just has to stay x squared. Then we have plus 3 squared. Well, what is 3 squared, or 3 times 3? We get 9. Equals 5 squared. Well, what is 5 squared? 5 times 5. We get 25. Okay, so now we can go ahead and start solving for x. So we need to look at our side with our x. Okay, so we have two things we have to get rid of in order to get x by itself, or do the opposite of. Okay, the first thing we have to get rid of is this plus 9. Well, what is the opposite of plus 9? We are going to subtract 9 from both sides. So we get x squared is equal to, what is 25 minus 9? 16. Okay, and one more step to get x by itself. We have, what is the opposite of square? We are going to square root both sides. Okay, so we get x is all by itself. What is the square root of 16? Or what number multiplies by itself to give me 16? Okay, we can check in the calculator. Second square root button, 16. And that gives me 4, because 4 times 4 will give me 16. So the square root of 16 is 4. And there we go. Okay, well, let's look at number 2. Let's identify A, B, and C in number 2. Okay, so this time my C is actually my X. Okay, that means 8 can be my A, and B can be 6. Beautiful. Now that we know that, let's go ahead and just plug it into our Pythagorean theorem. A squared, my A is 8, so 8 squared. Plus B squared, my B is 6, so 6 squared. Equals c squared, my c is x, so x squared. Okay, now that it's all plugged in, let's go ahead and start simplifying in order to solve. Okay, so we have 8 squared. What is 8 squared, or 8 times 8? We have 64. Plus 6 squared, what is 6 times 6? 36. And do we know x? No, we don't, so that just has to stay x squared. Okay, well, now on this side, we can add 64 and 36 together. Well, what is 64 plus 36? we get 100 equals x squared. Okay, in our very last step for getting x by itself, what is the opposite of square? We are going to square root both sides. That gets rid of that, so my x is by itself. Okay, and what is the square root of 100, or what is the number that multiplies by itself to give me 100? We get 10. So x equals 10. Beautiful. So that's how we can use the Pythagorean theorem to solve for missing sides of right triangles. Beautiful. Okay, so on 1 and 2, we've talked about this before, but these are called Pythagorean triples, where we end up with a nice pretty number with no radicals or decimals. Okay, so now on numbers 3 and 4, these guys are not going to be Pythagorean triples, which means the answers might not be too pretty. Okay, so again, we're still solving for missing sides. So we're still going to have to use the Pythagorean theorem. So let's go ahead and look at number 3. Let's identify A, B, and C in number 3. Okay, so across from our right angle is always our C, so x is C. Means 9 can be my A, 14 can be my B. Okay, let's go ahead and plug it into our Pythagorean theorem. A squared, my A is 9, so 9 squared. Plus B squared, my B is 14, so 14 squared. Equals C squared, my C is X, so X squared. Okay, let's do some simplifying. What is 9 squared? What do we get 9 times 9? That is going to give me 81. Plus 14 squared. If you need to use a calculator, that's fine. 14 squared gives me 196. Equals, we don't know x, so we can't simplify it, so it has to stay x squared. Beautiful. So now my x is almost by itself on this side, but we need to add these two together on that side. So what is 81 plus 196? Okay, well, if you add it to just your last answer, which was 196, we get 277 equals x squared. Okay, now my last step, what is the opposite of squaring something? We're going to square root it. So square root both sides, that gives me my x by itself. So let's see, I can't think of the square root of 277 off the top of my head. Whoops. So I'm going to use my calculator. Second button, x squared button, because it has a little square root sign above it. 277. Ooh, gives me an ugly decimal. Okay, so when it asks to leave it in radical form, that just means it wants the square root sign. So 277. And that's just how we are going to leave it. X is equal to 277. Great job. Okay, let's look at number 4. All right, this might look scary, but we're going to review how to take care of that. So first things first, let's always identify A, B, and C. So across from our right angle is always my C. So 12 is C. I'm going to make X my A and root of 17 my B. Okay, so let's go ahead and plug it into our Pythagorean theorem. A squared, so X squared, plus B squared, root 17 squared. You must remember that root, right? It's not just 17, it is root 17. Equals C squared, my C is 12, so 12 squared. All right, let's do some simplifying. Okay, we don't know what x is, so we can't simplify x squared, so it just has to stay x squared. Okay, but remember what happens when we have a radical and a square sign, or a square root and a square sign. They're the opposites of each other, which means they cancel each other out. Okay, which means you're just left with what's inside, so plus 17. They got rid of those two. Equals 12 squared. What is 12 squared? 12 squared, or 12 times 12 is 144. Beautiful. Okay, now we need to solve for x. So we're looking at this side. So I have a square and a plus 17 I got to get rid of. Which do I need to get rid of first? I need to get rid of my plus 17. So I'm going to subtract 17, do the opposite, do it to both sides. So I get x squared is equal to 144 minus 17 equals 127. Okay, my very last step, what is the opposite of square? How do I get x by itself? We're going to square root it because those cancel each other out. So I get x is all by itself, but what is the square root of 127? Okay, well, let's check in our calculator. Let's do square root, or second square root button, 127. And it gives me this ugly decimal, and it's asking for it in radical form, which means it wants the square root sign. So we are just going to leave it as the square root of 127. And there we go. Beautiful. Okay, so remember, they're not as pretty. They're not perfect Pythagorean triples, which means the answers aren't nice and pretty. But we can still leave them in radical form. If it asks for a decimal, like on your computer, on your test or an assignment, then you can use it in decimal form like it gave you on your calculator. Okay, so now we're going to get to the fun part, is where we are turning word problems into Pythagorean theorem problems. Okay, so it's asking us to solve the word problems using the Pythagorean theorem. Okay, well, let's look at number 5. So let's go ahead and read number 5. All right, and as we're reading, we might just draw a little picture. Okay, so a 15-foot ladder is leaning against the side of a house. All right, let's draw this. Okay, so I got my ladder here. Okay, it's leaning against the side of a house. I'm just going to draw that as my side of the house. Okay, the bottom of the ladder, which is right here, is 12 feet away from the bottom of the house. Notice how I'm underlining things that I might think are important. So we have 12 feet away from the bottom of the house. So this right here is 12 feet. Okay, well, what other measurement did it give us? It gave us 15 feet. It's a 15-foot ladder. So that right there is 15 feet. How high does the ladder reach the side of the house? Okay, so we're looking for this side right here. How high does it reach the side of the house? Okay, well, do you notice how we've created now this perfect right triangle? Here's our right angle right there. Okay, well, now we can use this to identify A, B, and C and solve using our Pythagorean theorem, just like up here. Okay, so if this is my right angle, let's identify A, B, and C. Okay, so my C is always across from my right angle, so 15 is my C. That means X can be my A, and 12 can be my B. Beautiful. Okay, so now let's go ahead and plug these numbers into our Pythagorean theorem. So we have A squared, my A is X, so X squared, plus B squared, my B is 12, so 12 squared, equals C squared, my C is 15, so 15 squared. And now it's just like what we were doing up top. We just had to give ourselves the triangle. We had to draw the triangle using the word problem. Okay, so let's go ahead and solve this. So let's do some simplifying so we can solve. Do we know X squared? Nope, so we just have to keep it X squared. But what is 12 squared, or 12 times 12? Okay, remember 12 times 12 is 144. Equals 15 squared. What is 15 squared, or 15 times 15? We get 225. Okay, now these are some big numbers, but that's okay. We're still going to solve it the exact same way. Okay, so we're looking at our side with our X. So I need to get rid of the square and the 144. Which do I get rid of first? We need to get rid of this plus 144. So we are going to subtract 144 from both sides. So we get X squared is left over here, equals, what is 225 minus 144? We get 81. All right, almost done. What is the opposite of square, or how do I get X by itself? We're going to square root it. Excuse me. Okay, so we get X is all by itself. And what is the square root of 81? Or is there a number that multiplies by itself to give us 81? Well, let's check. Second square root button. 81. Ooh, and we get a nice pretty number. X is equal to 9. Okay, so if we're going to put this back into the context of the word problem, we can say the ladder reaches 9 feet high on the house. Okay, so this right here would be 9 feet. And there we go. We can see how this Pythagorean theorem would work in real life. Okay, so let's do it one more time. All right, so let's go ahead and read our number 6, our last story problem. So we have a youth soccer field has a length of 14 feet and a width of 48 feet. What is the distance from one corner of the soccer field to the other corner? Whoa, what in the world? What shapes are soccer fields? Okay, so a soccer field is going to be a rectangle, right? Okay, well, it tells us it has a length of 14 feet, which means the shorter side is probably 14, right? And a width of 48 feet. Okay, well, what is the distance from one corner of the soccer field, so this corner, to the other corner? Okay, so we're looking for that distance right there. Well, you see, if we get rid of that half of our rectangle, how we've created this perfect right triangle. So we're trying to solve for x, the distance from one corner of the soccer field to the other. Perfect. So now that we've created this right triangle right here, we can identify its sides, A, B, and C, in order to find the distance from one corner to the other corner. Okay, so let's go ahead and do that. So I have across from our right angle is always my C, so x is my C. I'll do 48 as my A, and 14 as my B. Okay, so let's go ahead and plug these numbers into our Pythagorean theorem. So I have A squared, so 48 squared, plus B squared, so 14 squared, equals C squared, so X squared. All right, we're gonna get some big numbers, but that is okay. Okay, so first thing I need to simplify is this 48 squared. So I'm gonna use my calculator because I can't do that in my head. 48 squared, or 48 times 48, is 2,304. Okay, it's okay that it's big numbers, totally fine. Plus 14 squared, well, let's do 14 squared in our calculator. 14 squared plus 196 equals, we don't know x, so it just has to stay x squared. Okay, now we're just solving it just like we have in the past. So let's go ahead and add these two numbers together. So what is 2,304 plus 196? Well, I have 196. I just need to add 2,304. And I get 2,500, or 2,500, equals x squared. All right, now what is my last step for getting x by itself? What is the opposite of squared? We get square root. Okay, well, this is a big number, but that's okay. We can plug it into our calculator. So what is the square root? So second square root button of 2,500 equals a nice pretty number. X equals 50. Okay, so putting this back into context of our word problem, we can say it is 50 feet from one corner to the other corner. So we know that this distance from one corner to the other corner is 50 feet. And there we go. We have solved some word problems using the Pythagorean theorem. So that's all of your notes for today. You have an assignment that goes with it.